Hi, good morning, everybody. Thank you for joining us this morning. We are all here for the International Day of Permafrost.
Before I start, I just want to acknowledge that I speak to you from Vancouver in British Columbia, which is on the unceded territories of the Coast Salish people, the Musqueam, Tsleil-Waututh, and Squamish nations. I just want to give you a brief intro on ICOP 2024. So it's the 12th International Conference on Permafrost. And we're super excited that we can host this again. As we heard earlier today, there's been a gap for a conference that's been held every 4 years. This is a huge gap. So you may recall the last one was in Potsdam 2016. And so it's been 8 years since the international community had actually the chance to meet again. And it's been 26 years since the Permafrost conference has been in Canada. So we had one, 78, 98, and now 2024. So it's been a long time. And we've heard it already today. The permafrost community and the science has changed so dramatically. It's really time that we come together again and celebrate all the accomplishments. We're going to be in Whitehorse, which is located within permafrost. So it's sporadic, discontinuous permafrost, but there's a lot of permafrost sites to see around it. It is in the traditional territories of the Kwanlundun First Nations and of the Tanchaquechan Council. It's the largest city in northern Canada, now largest relative, so it has about 30,000 people living there. And it's really the center of the Yukon. And we're happy to have Yukon University as our host place. So we're going to have the conference there, who has a very strong permafrost research group. So it's really exciting. And I hope everybody's going to make it to that northwestern part of Canada. Just briefly over the organizations, and I'm putting it out there more to thank all the volunteers. So the conference will not happen without all the efforts from a big group of people that are involved in getting the conference going. What's important for you folks out there are the key dates. And you're probably aware, I hope so, that we had a call for sessions, and that just closed last Friday. So we already received a lot of good input on what sessions we're going to have. The session is going to be announced in about 2 weeks, but then we're really looking for input, and we're going to offer 2 ways of how to participate or contribute, I guess, to the conference. One is you can contribute in full papers. They're going to be peer reviewed, but also extended abstract. But we really like to go back to the legacy a little bit of the older conferences, where you can find very good full papers that are very useful. So maybe those younger researchers, if you have a chance and pick up all these old ICOP proceedings, there you'll find lots and lots of great stuff in those papers. And we'd like to go a little bit back to that history by offering papers that can be submitted. So here's just the deadline. So make sure that you keep those in mind so that we're all ready for June 16th, when then the conference starts. We'll have a very rough overview. So the conference will happen on 4 very packed days, Monday to Thursday. The Friday is a holiday in the Yukon. It's the First Nations and Indigenous Day. So that's going to be a holiday, and it would be great for people that visit to see all the festivities that have been going on there as well. Pre and post conferences, we're going to host some field trips, but also there's opportunities for meetings, short courses, workshops, and so on. One challenge to have it in a northern community is that we're limited in terms of participants. So we can only host 450 participants in-house. And that's why we also offer then a hybrid conference with online access. But even just if if everybody that signed up for this international day brings a body, we're pretty much full already. So that's a challenge to when you work in a smaller community up in the north. But we're still hoping that a lot of you can make it. And then for those that cannot travel, we're still going to have the hybrid model. And there's also opportunities for other meetings. And I think what today's day also shows is that these interactions really are great to have, and we want to host those. As I mentioned, the call for session proposal was out there. Here's just a snapshot of the width, I guess, of topics that were proposed. And I'm sure you're going to find something in a session where you can put your paper on. And last but not least, the field trips. There are going to be 5 field trips offered. We're still working on the details, specifically about the costs. Again, that's a major challenge with recent economic developments in northern communities. It's extremely challenging right now to cost anything 1.5 years ahead of time, because we really don't know how those costs are going to change. So that's currently a challenge we're facing. But we're offering these 5 trips, some pre, some post conferences, between 1 and 6 days, depending on where these trips are going. And yeah, with that, I really hope to see most of you coming and visit the Yukon, the beautiful Yukon. Here's just a view of Dawson City, to communicate, show your ideas, and yeah, and interact. And if you have questions or want to get even more involved, either visit our website or fire us an email at ICOP, Canadian Permafrost Association.ca. And with that, yeah.
Thanks, Lukas. Thanks, Lukas. That was great. And what a great invitation to join this international event in person in one of the most beautiful places in Canada. Before our next set of questions, we have Guido Grosse and Peter Pulsifer. Guido, we'll start with you from Permafrost Discovery Gateway.
Thank you very much for the opportunity. It's a great thing to present during the International Day of Permafrost. I would like to present a little bit about enhancing the accessibility of remote sensing big data for permafrost research. So that's a fairly new field coming up because we know that data is growing, especially in the field of remote sensing, and we need new ways on handling this type of data. And this is a collaboration with many projects here, actually. I'm presenting on behalf of Anna Liljedahl, actually, for the Permafrost Discovery Gateway, who couldn't be here today. So I will present partially on the Permafrost Discovery Gateway, but also on another project that is related to this. Yeah, why is this interesting? So permafrost landscapes are changing rapidly, as we know. There are a whole range of disturbances happening in permafrost regions, from fires, to erosion, to thermokarst, lake drainage, and so on. And they are happening across the landscape in many different places. We need to understand how fast they are happening. And so remote sensing offers some monitoring solutions for this. So they can help mapping landforms in permafrost regions. They help mapping geophysical and biophysical parameters in these landscapes and ecosystems, and they help detecting landscape change over time. So we can use time series of remote sensing, and what I'm showing here is one type of remote sensing, high resolution satellite data from commercial providers, from Maxar, basically that started in the 2000s, the early 2000s. So now we have more than 20 years of data where we can look at 0.5 meter resolution satellite images. So, and the animation on the right side shows basically the data availability. What you already can glimpse here is that in the early 2000s, it's pretty sparse, but the data density grows rapidly. So with more available sensors and satellites from the system, we are looking at more than 5 million scenes here. So we are going away from gigabytes and terabytes and entering the petabyte era of satellite data for a single system. And we are looking at many different systems now. So there's a rapid growth in data collected by satellites, but also planes and drones. And this basically is a challenge for us scientists, but also for communities and stakeholders trying to use this data. Remote sensing allows, on the one hand, quantitative understanding of rapid changes of these landscapes, can guide mitigation and adaptation measures. But the challenge is big data, 5 V's. So the increase in volume of data, variety, the velocity with which the data comes in, and then also the veracity, so how valid the data is, and the value of the data increases as well. So, and basically scientific and non-scientific users are really challenged by the rapid growth of this remote sensing data, but also the processing requirements increase rapidly. And the analysis methods change dramatically with machine learning, for example, or deep learning methods. So we need new ways for accessing and using information from these huge remote sensing data sets by scientists, but also by stakeholders and by the communities that are actually affected by the changes on the ground in permafrost landscapes. So this is the broad introduction. And the Permafrost Discovery Gateway is one project funded by NSF, the National Science Foundation in the US. And it funded several partners in the United States, so institutions and universities. And our institute, the AVI in Germany, is also involved here. The Permafrost Discovery Gateway is basically intended to analyze, process and analyze big geospatial data for permafrost regions. And the vision for this is basically to connect across scales and disciplines here, work towards near real-time automated monitoring of the pan-Arctic landscape using these really big remote sensing data sets and make this available to anyone on the internet. So the strategy is basically to create a web platform that simplifies this knowledge generation, but also the knowledge transfer. So one example that is happening within the Permafrost Discovery Gateway is the establishment of an operational mapping pipeline called MAPLE, in this case, a mapping application for Arctic permafrost land environment that uses AI methods, so artificial intelligence methods, in the whole processing pipeline to look into these very high resolution satellite images from the Polar Geospatial Center, from these Maxar data that I showed before. So these many petabytes of data, and extract information from them using supercomputing resources in the United States or NSF funded supercomputers to generate Arctic science product specifically for permafrost. And one field this is applied to is the first pan-Arctic ice wedge polygon map that's being produced. So basically machine learning methods are being used here on this petabyte scale imagery to extract information about these ice wedge polygons based on their trough and rim configuration or geometry. And this processing pipeline basically results in ice wedge polygons being extracted across the Arctic. So I'll show a quick animation here. So this is the viewer of the Permafrost Discovery Gateway. It's in the style of Google Earth, basically. So we can navigate here. There are a few products in there already, not too many, but this will grow over time. And this is the example of the ice wedge polygon map. You can see the animation. So it basically zooms in here to northwestern Canadian islands and goes down to the level of ice wedge polygons that have been mapped here across the Arctic. There are other examples, which I'm not going to show here. Oops. So what this data set, for example, contains are billions of polygons, of ice wedge polygons. This is a first overview of the pan-Arctic distribution of ice wedge polygons in terms of polygon numbers by region. So it's a pretty exciting product once it's finished. So there's still cleaning up going on. There's lots of information for each individual polygon basically contained in the database. And one idea is basically to also use it for quantification of pan-Arctic ice distribution at the surface, in the surface permafrost. So this is one activity, the Permafrost Discovery Gateway. I would like to also share a few insights into some activities that we are developing at AVI here within the pan-Arctic permafrost disturbance map activities that were funded from a number of projects, for example, the ESA CCI permafrost project, but also the Permafrost Discovery Gateway partially, and most recently the EU Arctic Passion project. So what we are doing is basically a first spatially consistent mapping of disturbances across the permafrost domain. So these disturbances include lakes and lake change, fourslands and fire scars, which you can see on the photos here. We use the full Landsat archive, so it's 30-meter resolution from Landsat 5, 7, and 8, from the 2000s basically, and process this data, which is also a very large data set. If you think about a pan-Arctic product at 30-meter resolution in Google Earth Engine, with some local processing also for machine learning approaches. So basically we stacked all the imagery, we created multispectral indices from the multispectral imagery, such as normalized difference vegetation index and so on. And we create time series and trends of this data. So here's a short insight into what kind of things we can see basically. So in these trends, we can detect lake drainage, for example, here. We can detect thaw slumping, coastal erosion, river change, and so on, fires, etc. And this information can basically be used with machine learning approaches to extract via segmentation, random forests, and so on, to extract individual features or objects of disturbances. So this is something that we are working on for the pan-Arctic scale. We have done this for very large transects across the Arctic continents, basically. But we are looking into a pan-Arctic or even global product here. So there's an app available within Google Earth Engine. There's a link here and a QR code that you can also use to explore the tool yourself. So that's very useful if you're interested in learning about disturbances in your study sites, for example, or at your community in the Arctic. So go there and browse and see what's happening around the landscape. So I'm just showing an example from Aklavik in northwestern territories of Canada in the Mackenzie Delta, a small village here in the Delta. So this is how the application looks like in Google Earth Engine. So this is a satellite image with hill shade. Then we have the DEM in there, the Arctic DEM also that shows the location and the topography. And this is basically what the disturbance map looks like. So Aklavik, and we see a number of changes happening here. So in yellow, there's lake drainages or drying of areas. In blue, we have lake expansion or river change and erosion. Here in the Pure River Plateau area, we have thaw slumping, like these small purple features, and a lot of sediment coming out of the river here, entering the lowland. And here, this final example, it's the last slide, also another example from northwestern Alaska. This is the village of Point Lay, where there was a lake drainage happening because the river here tapped the lake. And this was the lake that was basically supplying the fresh water for the village here. So this is Sentinel-2 imagery from before the lake drainage and after the lake drainage. So we see the transition here. And this is also showing up in these trend images or trend data sets as this orange color. But we also see coastal erosion, lake expansion, infrastructure change, and here barrier island migration. So this is very useful for Arctic communities as a tool to see what is happening around their landscapes. And we are working on a more sophisticated online viewer that is targeting these communities to explain a little bit better what is happening with these disturbances. Thank you very much.
So the next speaker is Peter Pulsifer.
Great, thank you very much. And I will share my screen as well. Peter Pulsifer, I used to be with National Snow and Ice Data Center at the University of Colorado, but I'm now at the Carleton University in Ottawa, Canada, on the unceded territories of the Algonquin people. I'm going today to talk about the Canadian Consortium for Arctic Data Interoperability, which is a joint effort with many partners. I have limited hotel bandwidth, so I'm actually going to turn off my video for now and I'll turn it back on later. So CCADI, as we call it, is a consortium, as the name implies, many different members. Our focus is on, as I'll explain later, on data sharing, interoperability, and so on. We primarily bring together folks from universities and other what we call long tail data partners. So not federal government, not the big corporations and so on, but those people who are individual labs, smaller institutions who may not have the resources or the partnerships needed to really work well in the data sharing space. So we have members and partners, including Permafrost. We also work very closely with a number of different international organizations and take leadership roles in their including the Arctic Data Committee, which I've co-chaired for a number of years now, initiatives like the Arctic Observing Summit, ArcticNet, and so on. So you can read the list there. I won't read them all to you, but I think that it's important for us to not only be thinking at a national level. We do think there and trying to do a lot of work in the Canadian landscape community, but also think about how does this connect up into these international initiatives. So I think that aligns really well with what I've been seeing here in all the talks from across the community. In the interest of time, I won't read out all the details of the slides, but I think the primary thing we're really focused on at the foundation of CCADI is interoperability. So how do we have these different information systems, databases, tools, applications, and so on, sort of talk to each other? How do we get working together, not only the data, but also the functions, the code, and all of those types of things. So the approach that we have taken in CCADI is we wanted to try and have some practical outcomes, not try and take on too much, put things into more manageable sub-projects. So we had a number of different use cases, we called them. And so one was working with our Indigenous organization partner in the Vural Regional Corporation, looking at what you see there, coastal archaeological sites. So that applied a certain type of interoperability, processing, and so on. Then as a contribution actually to the T-Mosaic project, we have Madaj. That's led by our partners at Laval University at Centre d'Études Nordiques. And so they're bringing together merged observatory data. And then we had a use case that we are just wrapping up a major source of funding or a major funding initiative that went for 3 years on the Canadian Foundation for Innovation, but we're heading into new sources of funding, including a partnership with Arctic Passion. So our last use case was ocean acidification. So we're looking there about how do we establish interoperability for oceans data. So interoperability is a pretty general term. There are lots of specific types of interoperability. So the first one that we really focused on, and this is in keeping with the trends and approaches in the international community, as well as metadata interoperability. And metadata, as you may know, is the data that describes your data. So it documents simple things like title and abstract, but all kinds of technical information as well. The challenge, of course, is that even though some of that's relatively straightforward, it's not fully interoperable. So there's still a lot of silos, so individual catalogs or metadata repositories that are not connected. So in CCADI, what we did was we came together as a community of Canadians, as I outlined in previous slides, and we agreed upon a set of standards, and including things like vocabularies, keywords, and so on. And we did this in concert with, or in collaboration with, the international community, their community initiative. And so we now have what are known as application programming interfaces, or APIs. So these are ways that anybody in the world can come and access the catalogs that are the CCADI family in an aggregated form, in a standard form. And so what we've done there is to, let's just give you a little view of what the code actually looks like. If you're a software programmer, you can send it a command, it'll return that to you, so you could use it in your own application. But many people are not software developers. And so what we have done is we have partnered with an international effort, which has put together an aggregation catalog that brings together almost, I think, 50 catalogs now. And we provided them with those APIs. They're now harvesting or aggregating that into this international effort. So you can go and search, and you will find all of CCADI holdings, which are in turn individual CCADI partner holdings from the metadata catalog. You can find things about, for example, Permafrost. So that was one of our areas of interoperability. Another is on data interoperability. There's a lot to say here, but I'm going to focus on the single biggest challenge I think facing us for data interoperability, which is not how do I get a file from one place to another. Well, we've known how to do that for a long time. There are many different systems, and you could go to all kinds of different, whether it be just downloading a file or an API, get the data. But when you try and use the data, you need to be able to synthesize it or merge it. And for that, you need to understand things like what we call the semantics or the parameter names. So if you're using different parameter names in the data sets, you're not going to be able to directly merge them. And usually that takes a lot of time to do that kind of work. So what we've been trying to do is automate that. And so we've created what's called a standards-based crosswalk ontology, which is just another name for a dictionary. So if it's in this term, what's the translation? That is then used with a standard query language, which then produces a standardized output. So when you bring in this case, it's actually data from the Arenson icebreaker. You bring that in, you translate it, and then put it out in standard format, which is British Oceanographic Data Center, which is a really well-used format instead of terminologies in the oceans community. So that is just sort of a glimpse of the data interoperability. It's great to have the data out there. And again, for those who have the technical expertise, they can access it using these different protocols. But we also worked a lot on developing different applications. And we did a soft launch in December at the ArcticNet conference, but we're now working towards sort of a more formal launch, probably around the middle of this year, on a number of these applications. So it's how do we get that aggregated, that interoperable data into something that's useful to end users. And so we have a number of different products. You see the MODAT website here. We're working on apps and visualizations and that sort of thing. And one of the big parts of that is the Polar thematic exploitation platform, Polar TEP. And David Arthurs is here. He's the lead on that. They're one of our key partners. And Polar TEP essentially is a platform that allows you to do all kinds of different things, including basic discovery, visualization, and so on, but also getting into modeling, programming, like Jupyter Notebooks, this machine learning component, and then getting into things like data cubes and so on. So this is one of these sort of downstream products that we feed the data into so that it's actually usable by the community. So that was and is part of our mandate. It's not simply to make the data available, but to actually use the data. And as part of that, it's also to share what we've done. So it is things like documentation products, how we've actually created these APIs, how we're making data available using and so on. So we have a publication stream going there as well. So just I'll wrap up by saying, lessons, it's actually should be, lessons learned, but community building, I think, is a big lesson learned. That's central to this whole thing. Is you need communication, you need to be bringing people together regularly and working together on this. If you want to adopt standards or best practices and so on, support interoperability, that's really a requirement. Another thing is to adapt and improve what's there. Sometimes you do need to create standards. I put that in bold, but that's a last resort measure for us. Is there are many things out there already, so we're trying not to reinvent those wheels, but to take advantage of what's already there and so avoiding this idea of the not invented here syndrome, which is actually an official thing that you could look up, or unnecessary expansion. And actually, Stefan Gruber forwarded an article to me once about this tendency for humans to try and make things bigger when in fact it might be more efficient, more effective to reduce the number of components in the system or solving the problem. And so we've been trying to do that as well, to simplify things as much as possible. And then we really realize you have to think right from the local up to the global. So you can't just be thinking at any scale. It all has to be together. And that fits back with the community building as well. It's not just having people up at the global level or down at the local level, but all together. So my last slide here is just one that is a metaphor that I use. I like to ride my bike. And I've realized that the fastest, the best way to ride fast and far on a bicycle is a peloton. And this involves having somebody up front doing what's called pulling people. They're cutting the wind. They're working really hard. You can see the expression on that guy's face. They're hammering away, but they can only do that for so long. And so to really go fast and far, you move aside, you let the person behind, come back in, you move to the back, and it keeps going. And it's incredible what you can do with this, how well it works. But it does involve trust. It involves allowing people to be out front when you're in the back and so on, but recognizing that you're all going to win at the finish line. It's the best way to go forward. So I think this is what I think about a lot about community building and trying to do all of this together is not just thinking about our individual success, but working consistency. So I'll stop there. I have a couple other slides that I put in the deck. I'll share the deck as well as the protocols we're using, but I'll stop speaking there.
Thanks, Peter. That's great. And that's a great metaphor to leave us on with the Peloton. I might just have to use that at another time. We're gonna spotlight Guido and Lukas as well. And feel free to write your questions in the chat. Lots of ways to collaborate online through applications, in person at a conference. There is a question already for Guido. Can you read it yourself, or I can read it? Maybe we'll read it aloud for people. About the PDG polygon map. Do you know if the detection algorithm uses angles values or can incorporate them? I looked at Cambridge Bay NU yesterday, and the building were identified as polygons. The buildings have 90-degree angle, whereas polygon angles, as far as I know, are usually wider. And that's from Adele Joyeux.
Yeah, thanks for the question. Very good question. So no, it does not use the angles per se from the mapping. It's based on machine learning, so it's a little bit a black box actually what is being used. I think it could use angles, but I'm not sure if it makes sense because there are polygons indeed that have right or orthogonal angles. So this is part of the cleanup operations basically need to be done for the whole polygon data set. But I'm not as familiar with how the cleanup actually will work. So that's part of Chandi Vitharana's work in the Permafrost Discovery Gateway. And so they're actively working on this. That's what I can say right now.
Thanks, Guido, and thanks for the question, Adele. So while we'll see if any other questions come up, but this is a really good opportunity. If you have a key message or something that you were not able to share, there is another question for Guido. But maybe for Peter or Lukas, if you wanted to share a thought, I'll come to you after before we go to the next set of speakers. So Guido from Pedro Freitas, thanks for your interesting presentation. Is it possible to download the data that is in the Permafrost Discovery Gateway at this stage?
So at this stage, it's not possible. So there is a vision of allowing interacting with the data. So right now it's just browsing. The idea is also because the data itself is multi-temporal in theory. So right now it's a snapshot, but there's a possibility to, in the future, to look at multiple time slices. And then we also would have to clarify how the data could be downloaded, because the data set itself is very, very big. So if you talk about billions of polygons, I don't know if you have handled large shape files in ArcGIS or QGIS. That's a gigantic data set, so it's not that easy. But definitely there will be a way to make it available. It might be through the Arctic Data Center also. So maybe there's a link provided to the Arctic Data Center. The Arctic Data Center itself is NSF funded and it's also involved in the Permafrost Discovery Gateway.
Thanks, Guido. The next set of speakers, it's the APECS Executive Committee. We have 3 speakers, Elise, Devoie, Deniz, Vural, and Lina, Madaj, who are going to present to us.
Hi, thank you so much for inviting us to participate. APECS is super excited to be a part of today. I'm here, personally, I'm situated on the traditional lands of the Haudenosaunee and Anishinaabe people here in Kingston, but I'm here with Lina and Deniz, who are taking time out of their relatively late evening over in Europe. So I want to thank both of you so much for being here today. And we're representing APECS, the Association of Polar Early Career Scientists, and Lina and Deniz will do most of the talking here. I'm just here to smile and change slides.
Perfect. Thank you so much, Elise. So hi, everyone. Greetings from Germany. And as Elise mentioned, APECS is a sort of umbrella for early career researchers who are keen on getting involved in and learning from peers and leaders, not only with permafrost, but also polar and alpine regions, as well as the wider cryosphere. So since the creation of APECS in 2007, which is as also as a result of the IPY, more than 7,500 individuals from over 100 countries have been members of APECS at some point during the early stages of their careers. So APECS here acts as a gateway, and this is definitely something that you can be proud of it. And on the right hand, the map you see where APECS has members. The countries in orange reflect APECS national committees, while the blue countries are the ones we have only APECS members. And speaking of the organization, it would be great to give a little bit of an idea about our structure. So if we move to next slide, we will be able to seeing, our leadership, containing our council, our project groups and project group leaders, as well as our national committees and other bodies such as advisory committee, project groups, and the directorate on top of everything. So in terms of APECS yearly defined priorities and ongoing collaborations and contact points between APECS council leadership and directorate, maybe here is the time to move to next slide, because here you will be able to see our EXCOM, the current EXCOM, which is the team of volunteers to help our project groups to move quickly forward, improve APECS pillars and collaborations, and be of help if there is any question to be answered or initiative is needed. So I will pass over to Lina here.
Thanks, Deniz, and thanks, Elise, for sharing all these slides. So I will also just say hi from Amsterdam. And I would like to give you a bit of an overview of like how everybody that is our member can actually get involved with APECS. So normally everybody who is a member can get active in the project groups, which are the main heart of APECS. So there's different kinds of project groups, such as, and you can see them all on the slide over here, such as some that are event-based, so they're organizing a conference or Antarctica Day or the International Polar Week, which you might have heard of, and it's coming up next month as well. No, this month, because we have March now, so end of this month. So stay tuned for that. But there's also topics as diversity, equity, and inclusion, or mental health, or we also even have a group that does do art. So it's like all kinds of different varieties that you can get engaged with project groups. We currently have 17 of them, but that's not limited. Like everybody that has an idea for a new project group can actually write up a proposal and suggest it to the current EXCOM, and then it might end up as a new project group that everybody can join. Can we get the next slide, please? Yes, so what kind of activities does APECS offer? So there is in-person and online career development, such as we have a lot of webinars that we share or that we collaborate on, or international opportunities such as fellowships or representative positions, meetings, and participation in meetings. They're sharing research and development and research collaboration through APECS. Then we have education and outreach activities and capacity sharing. And we're currently also establishing some social gatherings that APECS members can actually interact directly with each other in certain events. Can we get to the next slide? Yes, and some highlights. So what was on the slide, there's also a project group for it, is an online conference that is like a 24-hour conference organized by early career scientists for early career scientists. So it accommodates all kind of time zones. So everybody can join that one and get first experience on a conference where you do not have these huge conferences or more experienced researchers that you might be scared of. So that's a really nice way to get some experience of. And then we do have one project group that is actually also hosting a podcast. So if you are interested in podcasts, like we have all these amazing QR codes on the slide, like hop over to scan the code to listen to the podcast, but we are also happy to share it in the chat later. And then there's different rules of how APECS members can get involved as being representatives or write certain issues. Like you can see that there's an issue in cooperation with Interact that we heard about earlier today. So there was a few APECS members involved in writing this issue. And then I think I'm gonna hand back over to Deniz. Is that correct?
Yep. So our webpage, right? So there is a lot to discover there actually. As Lina mentioned some of them, you can always go and check what is happening, like as a job board, for example, or what XCOM actually discuss, or what are the very last news, the breaking news that I can get from the Polar community. So to be part of learning series provided by several programs and organizations to improve your skill set and get involved in working groups, depending on your interests through other Polar organizations, as well as extend your network and opportunities for your future career. I would say APECS is a great way of being involved and just improve yourself as your career goes. So if we can move to next slides. Yep, thank you so much, Elise. I know it's a bit pain, but yeah. So here are some of our partners that you are seeing, and actually thanks to them as well, it's growing day by day, and we are sorry if we missed some of the logos of our newly collaborated organizations, but as you see here, there are the organizations who already introduced to them today, and we are happy to be part of their initiatives as well as the new ideas that you will bring us, and we will be a part of it. Back to Lina again.
Yeah, so this is way more than just a like thank you slide for listening, because we also wanted to share that we have all kinds of social media channels to stay in touch. So you can follow us on Twitter and Facebook, on Instagram, and on LinkedIn, where we even have a group, not just a page to follow. And I also wanted to highlight we have a really great team of social media coordinators working on distributing all the information that APECS has. And you can all submit information to it if it's concerned for like any kind of early career scientist in the wider Polar community. We'll do have a link for that if you wanted to, so everybody can actually submit to our channels to share information that is valuable for all of us. So with that, I think I say thanks and hand over to Elise.
Amazing. Thanks so much, Lina and Deniz. Fantastic. And I would absolutely encourage anybody here, just as everyone else has, to come and join us, figure out what APECS is doing and see how we can support you developing your career and how you can contribute to shaping the future of Polar science.